Hi guys, welcome back to another video. Today we're going to be talking about different types of circuits. We're students from 9th grade in United Science Colleges. Then my name is Ranu Rewar, this is my friend Muhammad Falah. We're going to be talking about the differences and the properties about parallel circuits and series circuits. What we have here is a parallel circuit which is made from 3 branches of wires, and each lamp has its own individual way of turning it on and off. Even if a lamp is disconnected or it's turned off, the other lamps will work. For example, we took this one off, the others will work. Now we're going to try with the middle one. We're putting this back on, we're taking this one out, and the others will work. Why? Because they each have their own branches.
Also, I'm going to talk about series circuit. In the series circuit, the components have been connected by end-to-end system of end-to-end, and if one of the components have problem or broke or not working, there will all of the others will not work. Like if you look, we took this component off, and the others not working, different from the parallel. And for staying like that, let's pick this one off, and still the other will not work. Different from the problem is the component has been connected by one path, one branch, and this is the main problem, that if one of them doesn't work or have a problem, the others will not. Because if one of them have problem, one gap will be formed, and the energy cannot flow to the other components.
Now is that in parallel circuits, even if there is a gap for one of the branches, the other ones will work. Why? Because each of them have their energy flown to them by a separate branch, by their separate own wire.
In the series circuit, the current will flow by one path, and also it's because of that, where there is a gap, the current cannot flow to another one. And in series circuit, the current will not divide into the component. It will go by only one path, and it's different from the parallel. Okay, now we are going to measure the current in series circuit, and we said it's same because it will flow in one path. Let's check. If you look, okay, now we are going to measure the current in the series circuit. In each component, the measure of the current is 12 amperes, and because it's same in all of them, because the current will flow in only one path.
But here in parallel circuits, it's different. For example, if we have 30 amperes, they will be. But here in parallel circuits, it's different. We have 12 amperes, and for each branch, 4 ampere will go to each of the branches. Why? Because the ampere will be divided and will be equal surely by the branches. Now let's try and prove. We have 4 here, and we have 4 here as well. Let's try this out as well, and 4 here as well. And now let's turn the voltmeter to voltage. Now let's change the digital multimeter to voltmeter. Okay, now we have it on. Let's try out the series circuits first.
Okay, meter must be connected by parallelly, because one of them in this side and the other in the other side to the component. And if you look, it's 6. If you know from the power supply, we have 220, and each the voltage will divide equally to the component, and each of them have 72 voltage. This one, it's also the same, 72 voltage.
In parallel circuits, it's different. Let's try it out now. Here for this one, we have the maximum, which is 220, and let's try this one out. For this one as well, we have 220. Why? Because in parallel circuits, it's different. The energy will flow to the energy from the power supply will voltage will not cross the component and it will directly go to the lamp.